Okay, we have integral dx over 1 minus cosine x. So I'm going to use the formula sine square x is equal 1/2 1 minus cosine 2x. All right, so from here we are going to have, see here we have 2x and we end up half of the angle. So since I have here x, then I'm going to get sine squared half of x, right? 2 sine squared half of x. Okay, dx. So what I'm going to do now, 1/2 1 over sine squared half of x and dx. So I have here half of x, that means under dx I want to have half of x also, so I can take integral. Therefore this half I'm going to bring under dx. Based on what? Based on derivative of 1/2 of x is equal 1/2 and dx, right? So if I bring this 1/2 under derivative, nothing is gonna change, correct? It's a constant. You can bring in, you can take out. So I'm going to manipulate like that, and I am going to get here integral 1 over sine squared half of x and d half of x. Okay, now I have in shape where I can take integral. So 1 over sine squared, we know that 1 over sine, it's going to be cosecant, right? Okay, so let's write down. Why am I doing this? Because we have integral of cosecant squared, but we don't have integral of 1 over sine squared. That's why. Because derivative of cotangent, look here, derivative of cotangent x is negative cosecant square x, right? And 1 over sine squared x will be cosecant square x, right? That's why I'm using, because I don't have any direct derivative for 1 over sine square half of x. So this is the easiest way to go. Sine square, the cosecant square x over 2 and dx over 2. So this is going to be equal negative cotangent half of x plus c. Okay? Moving to next question. Now instead of cosine 1 minus cosine x, we are going to take 1 plus sine x. So I'm going to solve some elements of integrals. So whenever you have more complicated cases, you can put these pieces together. Okay, we have next question number 1, question number 2. So I have integral dx over 1 plus sine x. All right. This is equal. Dx. So instead of sine x, because I don't have formula for 1 plus sine x, and because here I have sine square x equal 1/2 1 minus cosine square x, right? And cosine square x, I have 1/2 1 plus cosine 2x. As you can see, I don't have combination formula related to 1 plus sine x. Therefore, I have no choice but sine convert into cosine. How I'm going to do it? From pre-calculus, we should know that cosine, let's say 60 degrees, equals sine 30 degrees, or rather saying it's equal sine 90 degrees minus 60 degrees, okay? Or sine, let's say 20 degrees equal cosine 90 degrees minus 20 degrees, right? Which is going to be cosine 70 degrees. Now, the thing is, when it comes to cosine, cosine negative x is equal cosine positive x. When it's come to the, we call cosine, it's a even function. Look here, if I have in the first quadrant cosine here and cosine here, right? It's sharing the same cosine, positive cosine, correct? Therefore, at this point, if I write down, let's say, cosine half a pi minus 30 degrees, I can put it equal cosine 30 degrees minus half a pi. Yes? Because positive 60 cosine, because positive cosine positive 60 equal cosine negative 60 degrees, right? Okay. Why am I saying this? Because instead of writing here cosine, let me write down this one. Instead of writing cosine half a pi minus x, I'm going to write x minus half a pi. Why? By what reason? I want the angle be positive one. X is my angle and I want it to stay positive because it's easier to work with positive. Okay, for that very reason. Okay, from here, now I can use 1 plus, where is it? Here, 1 plus cosine. See? Instead of 2x, we have cosine x minus half a pi. So it's not a big deal. We can take care of that. And that's going to be equal integral dx. So it's going to be twice cosine x over 2 minus pi over 4. Where from it's coming? Look, we have here cosine 2x, right, in the formula. And then we take cosine squared, half of the angle, correct? 2x, x. Since I have here x minus half a pi, right? If I take half, cosine squared, yeah. If I take half of this angle, it's going to be cosine half minus pi over 4. Yes? Okay. And from here, let me clean this drafting. So it won't take space. So this is going to be equal dx integral, let me put here cosine squared x over 2 minus pi over 4, and dx I want to have x over 2 minus pi over 4 also. Yes? So what's going to happen? Since this 1/2, right, I can squeeze under x over 2, and pi over 4 is a constant. If I take derivative, it's going to be 0, right? It can be any constant here. Therefore, I put minus pi over 2. Yes? I mean over 4. And from here, we will have 1 over cosine squared. It's going to be secant squared, right? Secant squared, half of x minus pi over 4, and d half of x minus pi over 4. And this is going to be equal integral of secant square is going to be tangent x by half minus pi over 4 plus c. I need to tell you that I don't memorize the values of integral, and I don't advise also to memorize integrals. As long as you know derivatives, that are already good enough, right? So how I'm doing, I have integral of secant square, so I'm thinking derivative of which function gives me secant square, and I know that derivative of tangent x is equal secant square x. Therefore, integral of secant square x is equal tangent x. And that's how I do. At least that's, I don't memorize integrals. I go through derivatives. Okay, let's solve next one. Integral 1 minus cosine x over 1 plus cosine x dx. So we have, it's one more time the formula, cosine square x is equal 1/2 1 plus cosine 2x, and sine square x is equal 1/2 1 minus cosine 2x. So what do we have here? 1 minus cosine x, right? This one is going to be sine squared half of x, right? And in denominator I will have cosine squared half of x. Yes? And dx. So if you are wondering what happened to coefficient 2, why I don't have coefficient 2 here, I do have it. It just both top and bottom, numerator, denominator, both of them have 2, so they cancel. It disappearing. Yes? Okay. So from here, sine square half of x. So I can take derivative of tangent if I divide, I can get derivative of tangent x squared. If I would have just tangent x, that would be easy. I would take it and solve it. But I have tangent square x, so I'm going to now simplify. Numerator bringing sine squared to cosine squared, based on the property that sine square x plus cosine square x is equal 1. So from here, I'm going to write down 1 minus cosine square half of x divided by cosine square half of x. See how beautiful it's coming out? If I separate them, 1 over cosine, it's gonna be the secant, right? And cosine over cosine is gonna be 1. So let's take care of it. I'm going to get 1 over cosine square half of x. I have here dx and minus integral. It's going to be 1, right? 1 dx, or just dx. Might as well. Okay, let me write down because I'm going to do some changes still. So let me go slow so some people won't wonder what's happening. Every time I'm jumping, I regret and go back and rewrite. So eliminate all possible questions. Okay, so now we need to take care of d half of x, right? Which we can solve very easy. And what I will do, take 2 out here and put x over 2 here, so they balance each other, right? 2 here, 1 over 2 there, so we are good. Cosine squared half of x, and minus this one, it's gone, so we get dx. All right, so the result is 2, it's gonna be secant square, right? 1 over cosine square is secant square half of x. Sometimes I put parentheses, sometimes I don't. It's not a big deal, actually. So it won't mistake if you won't put it, and it's not a mistake if you do put it. And d half of x minus integral dx. So the result is going to be 2 derivative of which function give us secant square? Tangent, right? It's going to be tangent x over 2 and then minus, well, derivative of what will give us 1, because this is 1 here, right? Derivative of x will give us 1, so it's going to be minus x and plus c. Okay, now I'm going to use advanced problem, solve advanced problem that's gonna involve several times substitution, and all these tricks that we learned here can be used there. Okay, all right, let's go. Okay, we have integral square root 4 minus x squared dx. Okay, based on habit that, or rather saying based on the method we learned, So when we have radical, we'll do substitution. I'm going to act as a learner and follow my thoughts, see how I will go, where I hit the bumps, and what changes I will do to avoid these bumps. Okay, so in looking at this radical, I know you would jump right away to do t, at least I assume you would jump and do the substitution, x 4 minus x squared. And from here take the derivative, would be dt would be negative 2x dx. Yes? All right. So, okay, we will substitute integral. So 4 minus x squared, it will be t to power 1/2. And dx to substitute with dt. So we will get dx would be equal dt divided by 2x, right? Okay. Here is the thing. Look, I am looking, I substituted by t to get rid of x and work with t. But, as you can see, I didn't get rid of x, which means this substitution is not going to work. So I am turning around. Okay. Now thinking different way. So I'm cleaning this because this is not working. So in some cases, when regular or standard substitution that we usually do for radicals or square root is not working, then we can bring in trig functions. This is how I'm thinking. Let's assume I am taking, that's your second attempt. Now we are bringing trig functions because what we tried, it's not working and there is nothing else we can do there. So now we can work with trig functions because integral, it can be radical, algebraic expression, and the trig function and exponent. So if I do exponent, it's going to take me even more in the woods and leave me there. So I won't be able to solve it. So I'm trying x is equal sine t. Okay. X is equal to sine t. Okay, no. Let's start with sine t. X is equal sine t. Okay. I'm substituting with sine t. From here, if I take derivative, dx of x is going to be equal cosine t and dt. Yes? Now, if I come back and plug in 4 minus sine, it's going to be square t, right? And dx, it's going to be cosine t dt. Okay, look what's happening. So, a little bit better situation. We have here sine and cosine. So, I can get sine and cosine communicate because if I take derivative of sine, I'll get cosine and life will be better with this case. But here is the thing, what to do with this 4. There is nothing much I can do. I can't separate even under this sign. I cannot do, let's say, square root 4 minus square root sine square t. Never ever. You can separate only when there is multiplication, but not addition, subtraction. Stick under square root. You cannot do that. So this is, so I need to a little bit adjustment. Seems to me I am on the right way, but here is a adjustment I want to do. Look here. I have here 4 and minus sine squared t. That reminds me somewhat 1 minus sine squared t equal cosine squared t. Yes? Okay. But here I have 4. How to make it 1? I can't. But what I can do, I can bring this one to the level of 4. How? I'm putting here 2 sine t. And as a result, dx will be 2 cosine t dt. Yes? So what changes we are going to do? So this 1 sine squared here will become 4, right? Sine squared t. And I will have here 2 cosine t dt. Okay, so from here, this 4, let me rewrite it nicely, minus 4 sine squared t. So 4 I can take out, will be out of square root, it's going to be 2, and this 2 I take out, right? And these 2 also I can take out, right? 1 will come out of this, from this 4 will be 2 and will come out, and the other one will come out from cosine t times 2. Okay, and I am getting integral of square root 1 minus sine squared t cosine t dt. Now, can you see the light at the end of the tunnel? We have 1 minus sine squared t, which is cosine squared t. Okay, so it looks like we are getting on the right path. So from here, 4 stays underneath. We are getting square root cosine squared t cosine t dt. Yes? From here, we are getting 4 stays there. Integral cosine t times cosine t, right? I took out of square root. Very good. And the result is I'm getting 4 integral cosine square t dt. All right. So I'm not going to go back as cosine squared t, put 1 minus sine squared t. That would be nonsense. But what I will do to get this rid of this square, I will write down the formula cosine squared t. Oops. Cosine squared t is equal 1 plus cosine 2t divided by 2. Remember that formula? Okay. So it's a double angle, right? All right, so from here, what we are getting, 4 integral 1 plus cosine 2t divided by 2 dt. Okay, this 2 underneath comes out. We get 4 over 2. And I'm getting 1 plus cosine 2t dt. Yep, much, much better. And this is going to be 2. I'm distributing dt. It's going to be integral dt plus integral cosine 2t dt. All right. So, what is it going to happen now? Let me see. I can take integral from dt, integral dt. It's going to be simply t, right? Well, to remind you one more time, when I have dt, that means I have here x to power 0, right? Because it's 1, so or dt. And as a result, we are getting x to power 0 plus 1 divided by 0 plus 1, so which is equal x. Therefore, x will come out of here, and we get 2t and plus, okay, 2 cosine 2t dt. I'm not taking integration yet because I want to do some manipulation and I want you to see. 2t plus. So this, look what I'm facing here. 2t here and 1t here. So either I have to bring cosine 2t to cosine 1t, or dt bring to 2 dt. It's easier bring this dt to d2t because I have here these two, right? Look what I'm doing. It's beautiful manipulation. Integral. These two bring under integral to cosine 2t dt. Now, these two, I can multiply either by cosine 2t or by dt. I'm going to multiply by dt. Look what I'm doing. Integral cosine 2t d2t. Where from it's coming? It's coming from here. If you have d2t, or let me take derivative like that for known as, okay, that's equal to and t prime, right? So I don't see why from here I can't come here and write down, so it will be d2t, which is equal to dt, correct? So I'll just take these two, squeeze underneath. Very easy. And that is equal, plus. And that is going to be equal to t. Now will be plus sine 2t and plus c. Hallelujah. We are done. And now all we have to do, bring back our substitution. Instead of t, we had what? Here, 2 sine t. Okay? So let me write down here again. We had x is equal to sine. Okay, so x, we are bringing back, right? From t, we are moving back to x. So we need t. We have x is equal to sine t, and here we need only t. So how we gonna work with this? We need to replace t. So if so sine t from here is equal x over 2. It's gonna be equal sine t, right? And t, let me tell you something. With if let's say sine t is equal, for example, how much to take? 1, right? And we know how many degrees is equal sine, with what angle equal 1? Here, right? It's going to be 90 degrees, correct? Sine represent y, right? cosine represent x. So when we say sine t is equal 1, then our t is 90 degrees. So the process of finding angle from given value of sine we will call arc, meaning arc sine backwards. So from here we can write down arc sine 1 is equal 90 degrees. See that? So we are coming backwards. If we want to find t, I'm writing down arc. There is no specific explanation to arc, but meaning arc meaning it's angle. So the angle of sine 1 is 90 degrees. Let me put this way. Yeah, that sounds good. Angle of sine 1 is equal 90 degrees. So from here, I want to get t. It's going to be arc sine of x minus over 2 is equal t. Yes? Okay. Now we can plug this back, and it is going to be 2 arc sine x over 2 plus. Now let's take sine 2t. Sine 2t I'm going to write down is equal, let me clean this drafting. Sine 2t is equal to sine t and cosine t. I have all this in my trigonometry. That's why I covered trigonometry before I started doing integrals and derivatives. So sine 2t is equal to sine t cosine t. Okay, so I'm going to write down here plus 2 sine t cosine t plus c. Okay, so from here, what is it going to be? 2 sine t we already know. Let me change the color so we will see. 2 sine t is x, right? Here. Let me write down 2 arc sine x over 2 plus, it's gonna be plus x, 2 sine t is x, or I can leave 2 since arc sine has x over 2, then instead of 2 sine x, 2 sine t, I can use only sine t and leave here 2. And let me see, leave here 2 and have x over 2, which means I will take only sine t, this one. So just to have a harmony in the answer, if it's x over 2, x over 2, okay. But if you take x, it doesn't matter, because it still will be correct, because 2 sine t is equal x, and you have here 2 sine t anyway. Okay. And next, cosine t. Let's work out cosine t a little bit. Because I don't have here cosine t, how I'm going to bring it. Cosine t is equal square root 1 minus sine square t, right? I'm trying to express cosine through sine, because we don't have any substitution for cosine, but we have for sine, and that is going to be, cosine t is going to be equal 1 minus, so if sine t, here, if sine t is equal half of x, then sine squared t, it's going to be equal half of x squared, yes? Okay. So x over 2 squared, right? And from here, cosine t is equal square root 1 minus x squared over 4, yes, or this is equal square root 4 minus x squared, which is equal 2, and square root 4 minus x squared. Yes, and from here I'm going to write down, and indeed, see, we have also x squared over 2, x and half, so it's going to be equal times square root 4 minus x squared over 2 and plus c. Hallelujah, we finished. Let me see how long, what a long, yeah, pretty long. Okie dokie, we solve it.